Every day, millions of people ask artificial intelligence to answer questions, generate images, write stories, translate languages, or create videos in seconds. To us, it feels almost effortless. Every day, millions of people ask artificial intelligence to answer questions, generate images, write stories, translate languages, or create videos in seconds. To us, it feels almost effortless. But behind every AI response lies an invisible world most people never see. Across the globe, enormous buildings filled with thousands of powerful computers suddenly come to life. Fans roar, cooling systems activate, electricity flows through endless rows of processors working together to solve incredibly complex calculations. The question is, as AI becomes part of everyday life, what does it really cost our planet? Is artificial intelligence becoming an environmental problem, or could it actually become one of humanity's greatest tools for protecting Earth? Let's take a look behind the screen. Artificial intelligence doesn't live inside your phone or laptop. Most modern AI systems run inside massive data centers, specialized facilities filled with racks of servers operating around the clock. Inside these servers are powerful processors called GPUs, or graphics processing units. Unlike traditional computer processors, GPUs can perform thousands of calculations simultaneously, making them ideal for training and running advanced AI models. Training a large AI model is one of the most computationally demanding tasks humans have ever created. Engineers feed these systems enormous amounts of text, images, videos, and data. The AI repeatedly analyzes patterns, makes predictions, checks mistakes, and adjusts itself, sometimes trillions of times. This process can take weeks or even months. Even after training is complete, every question users ask requires additional computing power. Now, multiply that by hundreds of millions of daily users around the world. All of that computing requires electricity, and electricity creates heat, lots of it. Without sophisticated cooling systems, these computers would quickly overheat. Some facilities use massive air conditioning systems. Others circulate chilled water through complex cooling networks. The digital world may appear invisible, but the physical infrastructure behind AI is very real. As artificial intelligence grows, so does the demand for computing infrastructure. One of the biggest concerns is electricity consumption. Modern AI data centers require vast amounts of energy, and the total demand continues to increase as AI services become more widely used. The environmental impact depends largely on how that electricity is generated. Data centers powered by renewable energy have a much smaller carbon footprint than those relying heavily on fossil fuels. Cooling systems can also require significant amounts of water in certain facilities, particularly in warmer climates where maintaining safe operating temperatures becomes more challenging. Another issue is electronic waste. Computer hardware eventually reaches the end of its useful life. As newer and more powerful AI chips are developed, older equipment is replaced, creating growing amounts of electronic waste that must be recycled or disposed of responsibly. Meanwhile, demand for AI continues to expand. New data centers are being built around the world to support increasing numbers of users and more advanced AI systems. These challenges are real, but they represent only one side of the story, because the same technology consuming resources today may also help us use Earth's resources far more efficiently tomorrow. Artificial intelligence is already helping scientists solve some of the world's biggest environmental challenges. One exciting application is renewable energy. Solar panels produce electricity only when the sun shines. Wind turbines generate power only when conditions are favorable. AI helps predict energy production and electricity demand, allowing power grids to balance renewable energy more efficiently. AI is also becoming a valuable tool in wildfire detection. By analyzing satellite images, weather conditions, and sensor data, AI systems can identify potential fire risks earlier than traditional methods, giving emergency teams more time to respond. Agriculture is another area undergoing transformation. Instead of watering entire fields equally, AI-powered systems can analyze soil moisture, weather forecasts, and crop health to deliver water and fertilizer precisely where needed. This approach reduces waste while improving crop yields. Transportation also benefits. AI can optimize delivery routes, reduce traffic congestion, and improve fuel efficiency, lowering emissions without requiring new roads or infrastructure. Conservationists are using AI to monitor forests, track endangered wildlife, detect illegal logging, and analyze environmental changes that would otherwise take months or years to study manually. Rather than replacing scientists, AI acts as a powerful assistant, processing enormous amounts of information and revealing patterns humans might overlook. The same computing power that consumes energy can also help humanity make smarter environmental decisions. The future of AI isn't only about building larger models, it's also about building more efficient ones. Researchers are developing AI systems that achieve better performance while using significantly less computing power. Hardware continues to improve as well. Modern AI chips are becoming faster and more energy efficient, allowing more calculations to be performed using less electricity. Many technology companies are investing in renewable-powered data centers, including solar, wind, and hydroelectric energy. Some facilities are even experimenting with advanced cooling methods that reduce water consumption and recycle waste heat. Software engineers are finding smarter ways to optimize AI, reducing unnecessary calculations while maintaining high-quality results. Sustainability is becoming an important part of AI development. The challenge isn't simply making AI more powerful, it's making it more responsible. Artificial intelligence is one of the most transformative technologies humanity has ever created. Like electricity, the internet, or the smartphone, its impact depends on how we choose to use it. AI does consume energy. It does require powerful infrastructure. And it does present environmental challenges that deserve careful attention. But it also offers remarkable opportunities to improve renewable energy systems, protect ecosystems, reduce waste, and help scientists better understand our changing planet. The future isn't simply about building smarter AI, it's about building AI responsibly. The choices made today by researchers, companies, governments, and all of us as users will shape how AI affects the Earth for generations to come. So perhaps the real question isn't whether AI will help or hurt our planet. The real question is, what kind of future will we choose to build with it? If you enjoyed this documentary, subscribe to AI Chronicles by Static Horizon for more deep dives into the technologies shaping our future. This is Static Horizon exploring the future. Thanks for watching. Please like and subscribe the channel for such more interesting topics to cover.